Let's go ahead and begin. My name is Daniel Noll, and I'd like to welcome everybody to today's webinar. It's part of the Edison Electric Institute Global Webinar Series. The title for today's webinar is Lessons from Control Technology Pilots for Integrating High Penetrations of Distributed Energy Resources, but you'll see on the slides actually what I think is a better title, which our colleagues from CEPRI have developed for today, which is Microgrid and Cluster Technology for Friendly Grid Connection of High Penetration Distributed Generation. Our speakers today are Dr. Xiong from the Microgrid Research Power Distribution Unit of the China Electric Power Research Institute, and also Wenyuan from the Secretary for International Cooperation. So just a couple notes for all of our audience members today before we begin. We will have a little bit of time at the end for questions and some moderated discussion. So please use the chat feature in the right-hand panel of the webinar software to submit questions to me in advance or as you think of them throughout the webinar, and then I will do my best at the end to get as many of them to our speakers as possible. So with that, I will introduce Dr. Xiong to give us your presentation.
Hello, everyone, and good morning, everyone, and good evening, everyone in the United States. Thanks for having us to introduce, like Daniel mentioned, introduce the microgrid and cluster technology for friendly grid connection of highly penetrated distributed generations, or HPDG. Yeah. So here are the main contents of our presentation. The part one is overview of renewable DG in China. The part two is solutions to friendly grid connection of HPDG. And in part three and part four, we will introduce the microgrid and the cluster technology in detail and give some, typical panels we participate in. And at the end of the presentation, we would like to conduct some prospects of microgrid and cluster technology. So the first one is the overview. Well, in order to introduce the development of microgrid and cluster technology, I would like to introduce the development status and trend of renewable DG in China. By the end of 2020, the installed capacity of distributed PV generation in China will reach 70 gigawatts. It's a huge number. With the focus on industrial parks and the rural areas. So a large number of distributed, intermittent, and random DGs are connected to the power grid, which greatly increases the complexity of the power grid and the difficulty of management and control. It has a significant impact on safe, renewable, and economical operation of the power grid. And at the same time, it brings great challenges to operation control and regulation of the power grid. So specifically, at the operation level, HPDG access to power grid makes system face a massive connection and processing information. And at the control level, HPDG access to power grid makes system electronically, which will reduce system damping and inertia, is not good for system stability. And at the regulation level, HPDG is to make system face a large number of units, which will make system scheduling difficult. So how to ensure that HPDG connect to the system in an orderly, renewable, and cost-effective way, achieving friendly coordination and efficient consumption of HPDG, it has become a major scientific problem and urgently in the energy and power grid. On part two, in combination with our mature technologies, we would like to introduce two solutions to solve these problems. The first solution is microgrid. as we know, microgrid it has a mature application around the world, and with the increasement of the penetration from distribution generation, multiple microgrids can coexist in one regional power grid. Through further coordination between multiple microgrids, it can maximum adapt to the dynamic characteristics of a HPDG. So what is microgrid? Here we give 4 typical characteristics. And the first one is miniature. And that means the voltage level is generally below 35 kilovolts. And the capacity is generally below 20 megawatts. And the second character is clean. That means the installed capacity, the installed capacity of renewable energy is generally above 50%. And the third character of microgrid is autonomy. That means system can operate in island model and with backstart capability. The annual exchange of electricity with the external grid generally doesn't exceed 50% of the annual electricity consumption. And the last one is friendly. Microgrid meets the power requirements of power supply and achieve friendly, flexible interaction between the external grid. So what goals that microgrid can achieve? Although microgrid has a mature application around the world, but it still faces so basically, as an important part of the smart grid, the microgrid is a major transformational technology for the use of distributed energy through the rational configuration and the coordination of multiple distributed energy sources. It can realize green, economic, and renewable energy supply under various application scenarios. And here are some normal operation targets. The first one is improve efficiency by local consumption of DJ and achieve friendly connection of DJs, enable power supply in remote areas, and improve power supply ability and recovery in disaster and emergency scenarios, and customize power quality and supply reliability requirements. Like I mentioned before, although microgrid has a mature application around the world, but it still faces 4 major technical challenges, includes system optimal configuration with coupled operating characteristics and system coordination, economic dispatch with multiple elements, system stable control under complex power electronics environment, and research and development of high performance power electronic equipment. So this is a microgrid. The second solution is cluster control technology. Well, this technology is an emerging technology, and it had a starting stage in China. So we also give the definition of a cluster. It's a number of DGs adjacent in geospatial aggregate virtual power generation set, which is controllable and schedulable. And the feature of cluster is the units in each cluster can be similar, heterogeneous, and complementary. And the capacity of cluster can be on watt, kilowatt, or megawatt, and the cluster can support access requirements for different penetration of DJ. This depends on different situations. We also conduct 3 operation targets of cluster technology. The first one is ordinary access to large-scale distributed generations to reduce difficulty of active management of power grid. And the second one is flexible grid connection to improve the interactive ability of large-scale DJ to the power grid. And the third one is optimize the scheduling to realize the economic benefits of large-scale DJ, and that's improve the ability of optimization. Like I mentioned before, as an emerging technology, caster technology faces four major challenges around the significant balance of caster flexible grid connected and caster consumption of HPDG. The challenges include system planning and multiple cluster collaboration, system optimized scheduling with multiple layers, and the system coordinated control with high density units. And the next one is research and development of efficient and flexible grid connection equipment, especially the electronic interface devices. So on part 3, I will introduce microgrid technology in detail, especially the products, the software, the core equipment we developed, and then give some typical panels we built. After years of technical accumulation and standard formulation, now we have a complete set of solutions for microgrid, like planning method, opera system, software, controller, and devices like the virtual synchronous inverter. This is the key point of our core equipment. These solutions can make a microgrid become more efficient, reliable, more safe, more smart, and more economic. For example, we developed the planning and the evaluation software for microgrid. This software has the function of graphic and model integration, typical scenario construction sim, distributed generations, optimization configuration, power flow calculation, sim comparison, and the evaluation of operating state. We developed the integrated operation monitoring platform. We can see in the picture the typical 3 control layer structure has been used in our research, and specifically we developed the intelligent protection. We developed the microgrid central controller, microgrid energy management, and this platform. And we also developed core equipment like a virtual synchronous generator. By simulating the electromechanical transient characteristics of the synchronous unit, VSG makes the power resources and the node using converter have the operating external characteristics of the synchronous unit, such as inertia, damping, frequency, and the voltage adjustment, which is really good for our system stability. And here are the series product consists of 10, 15, 30, 500 kilowatt PV VSG, 50 kilowatt, 500 kilowatt energy storage VSG, and container type manual level PV VSG. Yeah. So based on these products, software, and core equipments, we participate in the construction of several typical microgrid panels. The first one is a remote area microgrid. This one is to provide power supply for 120 household farmers and a milk station, and propose a solution to realize renewable power supply and economic operation in remote areas. And this is the first panel that we participate in to construct or build. So it has been operating successfully for 10 years. We get a lot of benefits from these panels. It includes direct economic benefit and the indirect economic benefit, specifically the annual income of microgrid and the DJ 190 to 1,000 China yuan. And we also get 16,000 yuan from net organ loss reduction and 336.6 thousand China yuan from operation cost reduction. And the annual economic benefits of resisting power interruption caused by some natural disasters are 400,000 China yuan. So this is our first panels. So we think it has a significant meaning for us to research microgrid. The keys to is coast area microgrid. On this panel, the project proposes a solution to realize renewable power supply and stable operation in coast area. So the key point of this one is the coast area. The third one is virtual synchronous microgrid. This microgrid panels project is a small power generation and distribution system. It combines virtual synchronous generation technology to increase the inertia and damping in microgrid. And like I mentioned before, it can improve the stability when the microgrid operates in disturbed circumstances. The fourth one is off-grid microgrid. This panel is a complex off-grid microgrid system with high reliability requirements and diversified distributed generation. And about 4 microgrid panels are all AC microgrids, and this one is DC microgrids. We using DC-AC converter to transform voltage from 10 kilowatts AC to 750 volts DC, and the nominal capacity of this panel is 1 megawatt, and it's used for industrial park, and it's also the first DC microgrid panel in China. The stator or need of local grid is the penetration of a distributed PV reaches to 12%, is really a big number for local grid to consumptive such a huge number PV generation. So the utilization of PV needs to be improved. And based on this panel, the efficiency of renewable energy utilization increased by 10%. And also the consumption of renewable energy increased by 20%. And the next one is AC-DC hybrid microgrid. The stator or need of local grid are DC node and the AC node coexisting in the regional grid. So the AC grid and DC grid need a flexible interactive control. And based on these panels, the local grid can achieve flexible and friendly interconnection between AC grid and DC grid. And also can meet the power supply requirements of different types of nodes. So this is the microgrid technology. Next one, we want to introduce the cluster control technology and some typical panels. Okay, firstly, I would like to introduce two typical panels directly, and also the only 2 panels in China. The installed capacity of renewable energy in local grid is 371 megawatts, consists of 335 megawatt PV generation, and the rest part are biomass generation. And the penetration rate reaches to 310%. And basically, there are 3 construction models for PV generation, as we can see in the picture. The first one is a roof model of farmer's household, and the second one is centralized mode for villages and the towns, and the third one is more power station model. So such a huge penetration brings greatly challenges to power dynamic balance, coordinated control, and economic optimization. So how to solve this problem based on cluster technology and like micro technology And the 3 control layer structure has been used in our research. We use this multiple control structure to realize autonomy within the cluster and realize the collaborations between the clusters. And the situation of case 2 is basically the same with the case 1. As we can see, the installed capacity of renewable energy is 203 megawatts, consists of 153 megawatt PV power and 50 megawatt wind power. And the penetration rate reaches to 216%. There are 2 construction models for PV generations. One is industrial park and another one is centralized power station. The multiple control structure is also being used in this case to realize autonomy within the cluster and the collaborations between clusters. And this is the 3-layer cluster control structure. You can see there are basically 3 control layers. The key point of the first layer is to realize faster response control and autonomous optimization within the cluster, so-called rapid control. The key point of second control layer is to further realizing the consumption of distributed generation through a power interaction between clusters, so-called coordinated control. And the third one is to realizing fully consumption of HPDGs and obtain some specific economic benefits through cluster power delivery from distribution grid to transmission grid, so-called collaborated control. Here is the specific control structure with specific functional modules. From bottom to top, the measurement and control terminal is responsible for connecting the operation information of each unit. This information is quite important for upper system. Upper system can use this information to analyze the operating state of whole system and formulate some control strategy or scheduling order for whole system to operate optimal. And the cluster control substation contains static cluster static regulation module and cluster dynamic regulation module. Well, the difference between these 2 modules is the time scale. That means the static module is for long-term regulation, and the dynamic module is for short-term regulation. And the distribution control center contains collaborative optimization module and collaborative control module. Similarly, the difference between these 2 modules is time scale. Again, the regional dispatch center contains a prediction module, communication module, and optimization calculation module to formulate the scheduling order for the whole distribution system, and then send the scheduling order to distribution control center. And the structure and the functional module of case 2 is also the same with the case 1. So due to the time limit, I don't introduce it anymore. So based on these 2 panels, we also get some benefits from these 2 panels. In terms of economic benefits, after installing the 3 kilowatt inverter control integrated machine and the 5 kilowatt PV energy storage integrated machine for the household power station, the problem of frequent disconnection of inverter caused by overvoltage was solved, and the PV generation increased significantly. The monthly average power generation is increased by about 35%, and it is estimated that the annual average income will increase by 1,000 China yuan. And in rural PV station, after installing our 30 kilowatt inverter control integrated machine, It also solved the problem of the inverter off-grid. It improves the quality of power supply and increases the monthly power generation compared with the conventional inverter of the same type under the same conditions. The monthly average increase in power generation is about 10%, and it is estimated that the annual average income will increase by 3,000 China yuan. And in terms of power quality, after installing our power quality control device, the total current harmonic distortion rate is reduced from 10% to 2.4%, which can meet the requirements of grid connection. And at last, it also can effectively reduce the peak to value difference of low voltage system, as we can see in the picture, the blue curve and the red curve, and also reduce the grid losses. So this is a cluster control technology. At the end of this presentation, we would like to conduct some prospects of microgrid and cluster technology. We introduced six different kinds of microgrid panels in this presentation. The first one is a remote area. Well, it has a mature application in China, Brazil, and the Philippines, and so on. The second one is coast area microgrid. It also has a mature application in China, Japan, and some European countries to ensure the continuous power supply for important nodes. The third one is grid-connected microgrid. It's currently staying in small-scale demonstration stage in China, and I think this one is the development of this one is depends on some policies and based on the electric market. The fourth one is self-synchronous microgrid. Is to improve the nature and damping of the microgrid stage, to improve system stability. Well, I think it is the future direction for microgrid development. And the fifth one is DC microgrid. Now it's currently staying on small-scale demonstration stage in China, also in Denmark and some European countries. The last one is DC hybrid microgrid. It has a certain application in China. The cluster scheduling and control technology of DJ is just starting in China, as I mentioned before. It is at the stage of theoretic research and engineering demonstration. Well, in the future, with the expected high density and the large scale of DJ access to our distribution system, and combined with the VPP technology, to develop the cluster control and cluster scheduling system, and some core grid-connected equipments that we believe that will have a broad application prospects in the future. So this is the whole presentation, whole contents of our presentation, and thanks for your attention. So if you guys have any questions, we can make a further discussion. Okay,
wow, wonderful. Okay, yeah, Xiong, thank you so much for that very rich and highly efficient presentation through so much information. I wanted to maybe begin with a clarification, because you presented a number of different sort of pilot projects for microgrids and cluster control technologies that have many similar things in feature. Both technology sets are methods of aggregating and optimizing the use of distributed energy resources. But there's also some key differences that I wanted to make sure that we clarified. And so, I think that microgrids are a little bit more well understood. They, it's a collection of technologies that are islandable from the main grid system, and they are located within a confined network boundary. In contrast, cluster control technology, I think you are using to describe the sensing and control technologies that can aggregate and optimize resources that are spread over a wider geography, and that there is not a firm boundary, network boundary between them and the connected grid. Is that correct?
Yeah. Yes, so I turn page. I turn to that page. Difference between microgrid technology and cluster technology. Yeah. As you mentioned before, the microgrid technology contains not only distributed generation like wind power, PV power, but also energy storage system and the different kinds of loads and some traditional generation like diesel generation.
Dr. Xiong, maybe could you please come a little closer to the phone? It's a little hard to hear you.
Okay, hold on, telephone.
Perfect.
So I say that again. Like you mentioned before, the microgrid contains. I turn the page on this page. Can you see it? The page change? Okay. The microgrid, and the cluster technology, a little bit similar, but is really different from these two technology. The microgrid technology, we can say the topology of microgrid, it contains not only DJ like wind power, PV power, but also energy storages and different kinds of nodes. So it is a tiny grid that contains another number of elements to operate, to coordinate these elements operated in orderly. But cluster technology, is directly faces is only contain distributed generation like PV power, wind power. With the because the difference in these two technologies configuration, so the operation target of these two technology is quite different. The operation target of a microgrid, the primary motivation of microgrid is to ensure that this renewable power supply, so stable operation system operation stability is the key point of microgrid. But cluster technology, its operation target is to to get some economic benefits. So this is the key point of these two technologies.
Okay, but it's also, is it correct to also say that the difference is in the ability to island the system or not, to close it off in case there's an outage or some other need to close it off? A microgrid gives you that capability, whereas the cluster control technology is more focused on providing upwards to the utility or to the grid operator different services that can come from resources spread out throughout the distribution grid.
Yeah, Daniel, I think your understanding is absolutely correct. Especially for us in China, the backstart capability and islandable capability is definitely one key point for microgrids control, because microgrids as itself is a small energy system or network. So the first thing for itself is to keep the stable operation of the microgrid and also provide certain support to the main grid at the emergency cases. And for the cluster control of distributed generations is because there's only some small energy resource scattered in the whole grid. So the key point is to help them to be more friendly to access to the grid and possibly provide some ancillary service to the grid operator. So your understanding is absolutely correct.
Thank you. Yeah, that's helpful. And I also just wanted to ask whether the cluster control technology is the same or has differences to virtual power plants, which also have a similar purpose in aggregating demand. Are these words describing the same thing, or is there some difference in what you are, the technology that you're developing?
Okay, Daniel is different. The cluster technology is away from the technique or the theoretic side to develop this technology to solve the HPDG access problems. But the virtual power plant that you mentioned is from the economic side or market side to solve the problems that HPDG brings. Yeah, Daniel.
Okay, thanks. I want to ask then another question. So you talked about these 6 different pilot projects. And you talked a little bit about the direction that you see for further research. Could you maybe also, though, summarize from a grid operator's perspective, what were some of the key benefits that you saw from the different pilots in terms of how well each a different technology performed for some of its intended purposes? You talked about some of the goals of sort of local load balancing or grid stabilization. What were some of the most meaningful results from these pilots?
So I turn to page 33, and we can discuss one by one. The first one is remote area microgrid. Like I mentioned before, although there are so many types of microgrid around the world, then to be honest, this one is the premier motivation that we develop a microgrid technology. Because the remote area, not only in remote area, but also flight, shape on that our traditional grid cannot reach it. So we're using the microgrid to solve the remote area power supply. So it has a mature application in the past, and we still think it will be widely used in the future. This is a remote area microgrid. Yeah. The second one is coast area microgrid. I think this one has a limited application due to it only can use in the coast area. It's limited by its regional restriction. So I don't think this one will get a wider area application in the future, the coast area. Yeah. The third one is a grid-connected microgrid. This one, due to the grid-connected microgrid closely connected to our traditional power grid, so we can see this type of microgrid everywhere, at the school, building, hospital, and industrial park and scientific park. So we can see the area well, and we can do a lot of optimization between external power grid and microgrid. So to achieve some special operation target, get some economic benefits. So I think this will be a good use in the future. And actually, Chinese government communicated a lot of policies on this one recent years. But like I mentioned before, the development of this one depends on whether there is a further policies to communicate or the electric market, whether the electric market will be more open. So this is the key point. The fourth one is self-synchronous microgrid. Like I said before, it can improve the initial damping of microgrid stage. So it has a great significance for our microgrid stability. But I think the development of this one depends on the construction cost of virtual synchronous generation, because the VSG product is really expensive right now. So that depends on whether the price of VSG will be down in the future. And the DC microgrid, I think will be widely used in the future. But that depends on whether that depends on how much DC type generations and how much DC type nodes will occur in the future. For example, if all the generations and the nodes are DC type, then we can decide that the DC microgrid is absolutely better than AC microgrid. But it will for a long time. So for a long time, the next one, DC AC hybrid microgrid will be a good transit. Yeah. Thank you.
Okay, thank you. I wanted to go back also to the slide that you used to show the different levels of system control for cluster control technology and the pilots. I think it was page 27. Yeah. Oh, no, it was a little later. You passed it. It was, I think, 27. Yes. Could you talk in more detail about this slide and to talk about some of the control technologies that sort of optimize these functions across these different layers of control?
Well, like I said before, the three control structure is the typical control structure, not only for our traditional power grid, but also for microgrid, DC distributed microgrid but also for the cluster system. In the premium control layer, each unit will adjust its output only based on the local information, not the information from upper system or scheduling order from upper system. So that's we so-called adaptive control. The second control layer is about central controller. The main function of this controller is to realize quick switching between different modes of system, and also receive the scheduling order from upper system, like the energy management system, and then check it out whether the scheduling order whether the units in the system can follow the scheduling order, and then send the order to its units. And the upper system, energy management system, as we know, the main function of AEMS is to, based on multi-time scale prediction data, to calculate multi-time scale operation, multi-time scale optimization, scheduling order for each unit in the system, and to ensure that our system can operate in stability or get some economic benefits. So this is a typical one, typical structure for our power grid. Daniel.
Okay, thank you. Yeah. So what's next for your research and for the demonstration of some of these technologies? Are you looking to move to larger pilots, or are there other technologies beyond these two that you're also looking to experiment with for solving some of the issues with distributed generation?
Okay.
For microgrid technology, I think there's a technology like mentioned before, multi-microgrids. So maybe the multi-microgrids panels will occur in China, not only in China, but also some little countries like European countries, Japan in the future, multi-microgrids panels. And beside the microgrid technology, you said that you mentioned before the VPP technology. It also can, I said before, can solve the problem that brings from the HPDG excess. But I don't think VPP technology will have a wider use in our country, because the VPP technology is based on the policies and the market, and our market is not open, so it's not suitable for us. Maybe in United States, or Another one is a multi-energy system. Yeah, it's not that means not only contain the electricity, but also contain the gas, heating, gas, and so on. Yeah.
Okay, great. Yeah, thank you. Maybe just a final question. What are, when you look at all of these pilot projects together, what is your feeling about the future role for distributed generation in China? You showed at the beginning a very aggressive forecast for 70 gigawatts of distributed generation in China. Based on these early pilot projects, does that number give you concern, or are you more optimistic about the ability to integrate that amount of distributed generation into the grid in an effective way?
Daniel, I'm going to share some points from my perspective. For China, like many governments around the world, we have an ambitious goal to use energy more clean, more green. So there are definitely two ways to use that. One is in the large scale, one is in the distributed way. And for the situation in China, the load center is more in the east and the south part of China, which are like very condensed cities. So for this kind of areas, distributed generations definitely will play a more and more important role. And also with our distribution system operating, becoming more controllable, visible, and flexible, we are confident to integrate more distributed generations in the future. And also as a being a responsible utility in this country, we not only have the responsibility to operate this as a company, but also to undertake some social responsibilities. So the goal is very clear, and we have already found the technology solutions and keep digging on this direction. So we're confident and to the future, and renewable distributed generations will definitely play a more and more important role.
Thank you, Wenyuan. I would guess maybe as a leading question to wrap things up here then, that for other utilities or researchers who are interested in following up and sharing information with you about their work in this area, that they could contact you and get in touch with your contact information?
Email address, also the phone number on the next page. We're welcome to any questions and cooperations from all around the world. Thank you.
Great. Okay. Well, Wenyuan and Xiong, thank you both so much for today's presentation. And for all of our attendees, the recording of this will be made available with the presentation shortly, and will be emailed to everyone in the next few days. So thank you once again, and take care.